It's a foundational lesson, so it's not very hard, but it is very important. So alternating series are a huge part of Taylor series and stuff to come. So you need to get acquainted for a series that isn't always positive terms like we've been dealing with, right? Would you consider this infinite geometric series? And what I want to do is sketch the partial sums. So as we add terms, what do the partial sums go to, okay? So S1, or the sum of the first term, is 16. 16. Cool. Partial sum 2. 8.
-8.
Negative 8 or 8?
8.
8. Not term 2, partial sum 2. So the sum of the first two terms. Are we good? Okay. Sum 3, or the sum of the first three terms. 12. 4 terms. 10. Okay? Now you can see that it's spiraling in, and that is a characteristic of alternating series. There's positive and negative causing it to go up and back down and up and back down, so on. So if I were to find the infinite sum, what does this sum approach? First of all, is this a series for which I have a method of finding the sum? What are the two types of series I can actually find a sum for?
Geometric.
Geometric and telescoping. All right, so this is geometric. Does it meet the conditions for convergence and use of the formula?
Yes.
Yes, the common ratio, the absolute value of the common ratio is the absolute value of negative 1/2, which is less than 1. Yay? So by the formula A1 over 1 minus R, A1 is 16. The common ratio is a half or negative a half?
Negative.
Negative a half. 16 over 3 halves is
32 over 3.
32 over 3, or 10 2/3-ish. Does that look like it was what it was spiraling in towards? 10-ish?
Yes.
That makes sense. Okay? All right. Now, it doesn't have to be geometric. You can have alternating series that have something wacky, like factorials or exponentials and stuff. So there are lots of different alternating series, not just geometric. That said, the divergence theorem still applies. The terms still must go to 0. Otherwise, if they don't, then while they will go back and forth, they will spiral out, not in. And so the terms still must go to 0. Understood?
Okay.
All right. Now then, let's talk about the effect of that alternating negative on convergence. What does it do to convergence? So let's say we look at the harmonic series, and by we, I mean I already did all the work for you. You're welcome. Okay?
Yay.
So if I look at the harmonic series and I add increasing orders of magnitude, it gets bigger, and it doesn't get bigger very fast, but it does always get bigger. It never converges. 1 over n is just at the cusp of a p-series that converges versus diverges. It is the last, you could say, diverging before we head into above one, which converges. But if you were to throw on an alternating negative onto the harmonic series, and before we get to, actually you can see that this does not spiral out of control. You can see that as you add more and more terms, maybe 100,000 terms, you start to get towards the limit, yeah? Now, it helps actually to, let's do a term or two. If you start with maybe, the first one is positive or negative 1 over 1.
Positive. No, negative 1.
Negative 1 over 1 plus 1 over 2. When we go to a even exponent becomes
Negative.
positive. We go to a negative exponent, odd exponent, back to negative, even exponent, and so on, yeah?
Yay.
Now, if we were to do partial sums here, I'll make you do some of the work. What's the first partial sum?
There is -1.
Negative 1. What's the second
-1/2.
partial sum? Negative a half. Now add in a negative a third. What's negative a half and a negative 1/3? Negative 5/6, which is about here, yeah? And what's negative 5/6 now plus a fourth? Negative 7/12, which is a little above. Now you can see then that it's spiraling in because of that up, down, and the terms are getting smaller. It starts to spiral in. Now the big idea of the day then is an alternating negative aids convergence big time. Because it contributes this back and forth kind of thing, and it keeps it from getting too out of control in some cases, like it did in the harmonic case. Now, some series, like the one we just said, only converges if you have this alternating thing. This is called conditional convergence, which is to say it converges on the condition that that alternating negative is there. And if that alternating negative was not there, it would diverge. We'll prove conditional convergence later. That's Leibniz theorem. We'll come to that later. But for now, a wee bit more vocabulary. Now, if a series doesn't even need the help of the negative, it would converge if it had the alternating negative. If it didn't have the alternating negative, wouldn't matter. It still would converge. Then the series converges absolutely. Think absolute value. Remove the sign. If it would converge absolutely, it means I wouldn't even need that. For example, say this series. And that's an alternating series, but if I took out the negative, what would it be? It would be a P series that converges, right? That's a series that converges absolutely. What? What?
We're just reading your handwriting.
Oh, okay. Alrighty, so let's talk about what this looks like. If any series, usually alternating, if you're given an alternating series and the series after removing the absolute value converges, in other words, even without the negative it still converges, then you would say the series converges absolutely. If, however, you take out the alternating negative and the series does not converge absolutely, then you could say it doesn't converge absolutely, but as far as it might converge conditionally, we'll prove that later. For now, you'll just say it doesn't converge absolutely. Maybe it would with the negative, all right? Let me give you an example or two, all right? So the question is, does this series converge absolutely? And by that means if you remove the alternating negative, does it converge? That's what that's code for, yeah? So the first thing you'll do is say something like the absolute value of the series, and I usually just write it that way so I don't have to write the whole stinking thing over again. If I remove the sign, it becomes just 1 over n factorial. Now I need to get into, does that converge? What do you think? Can you tell me what the answer is going to be? It does converge because what test? Ratio test. Okay, it will converge, but we do have to show it as much as I like to say. It would converge by the ratio test. We have to prove that. We can't just say it because then some knucklehead would say stuff that's not true. You have to prove it. So here we go, by ratio test. The limit as n goes to infinity of the nth term to the next term. I remind you just by way of review, I would care that you show me one of those two first steps that I've shown. One of these would communicate, hey, I'm using the ratio test. You got it? After that, how quickly you do the limit. Let's talk about actually showing how does the cleanup go? How do we clean up?
The n plus, the n factorials cancel and you get n plus one.
So by breaking n plus 1 factorial up into n plus 1 times all the stuff beneath it, which is n factorial, the n factorials drop. And when they do, 1 over n plus 1 goes to 0, which is less than 1. Now the conclusion would be something like the alternating series converges absolutely. Or the given series converges absolutely, the original series. You follow me? All right. Let's try. I wonder if I think I have a mistake there. I'll talk about that in a second. Okay. That's just notes. We did that. All right. So this guy, we will say that first thing we do is remove the negative, yeah? If I remove the negative, then the series becomes
N over n squared plus 1.
n over n squared plus 1. How do you want to prove convergence or divergence of this? I can not integral test?
No, it's
all right. Limit comparison test. By the limit comparison test to harmonic, we would say something like the limit as n goes to infinity of the given function as compared to 1 over n is, what is the limit? 1, okay. So we would say something like 0 is less than the limit of 1, which is less than infinity, and the series 1 over n diverges. Why do you say it diverges? Harmonic. So the series diverges. The positive series diverges. What does that imply for a conclusion?
Nothing. Well, it's not.
It does not converge
Absolutely.
absolutely. Okay, the alternating series does not converge absolutely. Okay, you follow? All right, this is supposed to be cosine of pi, and I apologize. Would you change that to cosine of pi? So what does this have to do with anything? Does it feel alternating?
Yes.
Yeah, when n is 1, what's cosine of 1 pi? Negative 1. When n is 2, what's cosine of 2 pi? Positive 1. 3 pi? Negative 1. This is another way of doing an alternating negative. It's not used as much. It's kind of a tricky deal. But be aware that when you see something like that, it is also producing an alternating sign case. All right? So, that said, then, gosh, what about this? Does this converge absolutely? How will we get into it? So if I take the absolute value, what do I get?
You just get 1 over 2.
1 over 2 to the n. Okay, you follow? All right. Does that converge or not? Converges because it's geometric with r of 1/2 less than 1. So what do we conclude as far as answering the actual question? Does the alternating series converge absolutely? We would say the alternating series converges or diverges? Converges absolutely. You down? Okay, cool. Try the last one.
There's a few more.
Not the last one.
Oh, sorry. Try this one. How's that sound? I need to know if you need to do the absolute value. That's okay. So what's the absolute value? 2 to the n. Converge or diverge? Why? I just said divergence to myself. The limit of the terms is
3
infinite. Yeah. The terms are getting bigger. It has 0 chance.
Yes.
And so what about the alternating series? The alternating series does not converge absolutely. All right. How's that going so far? Okay, you try a couple and then we'll go over them. How are we doing? A lot of writing, yeah? I did a limit comparison test on the first one. How about you? All right. And did you get, now, it's important that you speak clearly with subjects here. So when you say, I want you to avoid saying the series diverges because there are 2 series at play here, the positive term series and the alternating series. So you should say something that identifies something like the positive term series diverges. Therefore, the alternating series does not converge absolutely. Yeah? Okay, cool. Do we have any questions on it? Cool, Mindy. What about the next one? If you put -2 in for x, the top's going to grow, but the factorial, will it balance out? Which one's going to get bigger faster, factorial or geometric? Okay. What about what test did you use when you removed the sign?
The ratio test.
The ratio test. So it becomes 2 to the n over n factorial, yeah? Oui? Oui. Okay, cool. So by the ratio test, did it converge or diverge? Converge. Do I need to show that, or would that go okay? Okay. Hopefully you said something like the positive series converges by the ratio test because the ratio of 0 was less than 1. So our conclusion is the alternating series converges absolutely. Oui? Alrighty. Is that the end of the notes? Yay. Okay, cool. Homework. What homeworks do you have?
We have 134.
134 and 134 extra practice. Okay. What else do we have on 134? 25. That was 100.
21.
That was today's thing.
21. What else? 22. Did you say 14? All right. Which way you look at it, we gotta get caught up here. All right. All righty.
Mentality was so great.
Okay. Yay. 25 is cool. So it's a 100-meter long field, and he starts at one end. So he goes all the way to one end, and then halfway back, and then halfway back the other way, and then halfway back the other way, and halfway back the other way, and so on. Yeah?
It's today's thing.
It is. Although you could do this with a good pre-calculus. Yeah. So when I want, what do they ask for? They want distance and position, yeah?
They want where it converges to and blah, blah, blah.
Okay. So when I want the position, do I need to take into account the direction?
Yes, you do.
I do. Okay. So if I want the position, I want to say he goes positive 100. Then, because it's going backwards, he's going to go negative 50. But then right, so plus 25, then left, negative 12.5, and so on. Now I can look at partial sums and see what they approach. 50, 75, 62.5, 68.75. It's in the 60 range, yeah?
Yeah.
What kind of series is this?
Infinite.
Infinite geometric. What is, and it is converging, what's A1? 100. What's the common ratio? Negative 1/2. And so that's 100 over 3 halves, which is 66 and 2/3, or 200 thirds, or something like that, yeah? And that actually makes sense with our partial sums. They seem like they were in the 60s region. Are we good on position?
Yeah.
Okay, now when they say distance, do I care about direction?
No.
So I want to remove the sign, yeah?
Yeah.
Distance, you remove sign. So it would be 100 plus 50 plus 25 plus and so on. Is that a converging geometric series? It is. A1 is 100, 1 minus, but this time the common ratio is 1/2. half, 100 over a half is 200. That also makes sense because 150, 175, 187.5, 193, etc., etc., etc. Does that make sense? Okay, 21. Is 21 still a question? Yes, no? Whoever has 21? Do you need 21? No? Make sure you divide first. Okay, guess not 21. 22. Okay, 22. All right, so this is a check to make sure you're developing good habits. What's the first thing you got to check?
That's linear.
Not linear. Is it continuous on the interval? Is it continuous?
No.
It is not. Here's cosine. Here's secant. Yeah? So, we need to approach pi over 2 from the left with A and the right from B, yeah? So did you get something like the limit as A goes to pi over 2 from below, 0 to A? Secant of x dx. Are we cool? All right. Is that how you started, or is that the problem? Shall I continue, or? Okay. What is the antiderivative? Secant. That's your log of secant plus tangent. Was that the problem, or no, you do that, that wasn't the problem? That was the problem, okay. Does anybody need me to keep going? All right. I believe this headed for indeterminate towns, didn't it? Or did it? Is it indeterminate? All right. I think I got two different limits of infinity that couldn't be combined, so it. I'll watch.
Well, so technically it's the same infinity though. It's the same.
No.
Well,
Why?
um,
Oh, okay. Yeah, it's two different. A and B
well, like,
are like two different people.
mathematically it's different, but you like on the graph because of the way the behavior is assigned. Well, I mean, secant curve works.
That's true, but that doesn't mean A goes towards that pi over 2 at the same rate as B goes towards. The graph is symmetric. I don't argue that, but A and B don't approach pi over 2 at the same rate. Yeah. 14. So is 14 a no? Okay, 12. Cool. 12.
Well, no, but like this.
See, I tried to scratch some of these questions. 12 and 14. Okay. All right, 12 real quick. The equation of the tangent. Is this the one that scoops me out? I can't remember if this. Okay. Maybe a little hint here that is icky is to think 4 pi over 3 is here. I wasn't sure exactly what the slope is. Your picture has to be really good to tell if the slope's, I know it's steep, but I don't know if it's steep positive, steep negative, vertical. I don't know. In the interest of time, I would typically find the point first, and I will if I need to, but I'm going to find the slope first. I think you'll agree that x is r cosine theta, so that's 2 cosine theta plus 2 cosine squared theta for x, and y is 2 sine theta plus, and then 2 cosine theta, sine theta is sine 2 theta. Are we cool on that? And I can find the point in a second, but I just wanted that to look at when I find the slope. I don't remember if this is vertical or not. All right. Do you agree with my x's and y's? Okay, cool. So dy d theta is 2 cosine theta plus 2 cosine 2 theta And dx d theta is negative 2 sine theta plus 4 cosine theta negative sine theta. Okay? At 4 pi over 3, maybe I'm not getting this right, I thought this zeroed out. At 4 pi over 3, the top is 2 times negative 1 half plus 2 times cosine of 8 pi over 3 is 2 pi over 3. That's also negative 1 half. Wow, these are a lot of work, huh? 4 pi over 3 is negative root 3 over 2. And cosine of 4 pi over 3 is negative 1 half. Maybe I'm mistaking this for another problem. I'm not seeing this zero out. Did this zero out? Oh, it does zero out. Negative root 3 over 2. So you get vertical slope, yeah? So a vertical tangent line, is that x equals a constant or y equals a constant is a vertical line? Which of those represents a vertical line's equation? X equals a constant. So now I know it's some kind of vertical line. I just need to know what is the x and what is the x. 2 times negative 1 half plus 2 times negative 1 half squared, negative 1 plus a half. I'm getting a line of x equal negative 1 half. Please tell me that's right. Okay, cool. That was a humdinger. These are a little tedious. All right, 14. Question on 14. Yes? No? Yes? Okay. This one's definitely calculator active. Theta equals 2 isn't a reference angle. So, in terms of the work I'd like to see, theta equal 2, I would like you to tell me, hey, this is how I found x. X is 4 cosine 3 theta times cosine theta at 2, and that is blah. Y is r sine theta, so it's 4 cosine 3 theta times sine of theta, and at 2 is blah. Are you okay with finding the x and the y via calculator? Are we cool? The slope, I would communicate, hey, I'm finding dy dx, but that's dy d theta over dx d theta, and that's where I definitely go to my calculator. In one big old fat calculation, I would say that slope is, and then put your pieces together into a tangent. Okay? If you are having trouble getting that in your calculator, let me know. I'll be happy to talk to you. Okay. Can we go through a few quick answers to 134 extra practice? Okay, for the front sheet with staple, did you get number 1 is C? 2A. 3B. 4E. Right. 5 is hideous. Wow, no calculator. That was mean. So there's your line.
I did it!
Thank you.
Is that what it looks like?
Well, wait, why is that more?
Why is there an X? Because it's a line, silly. It says whole line, so yeah. Wow. So did you sketch afterward and say, yep, that's that line, all right? Yeah, right.
Oh, yeah, totally, for sure.
6. Okay. So this, actually, I shouldn't give this to you. This is a good, this is meant to stretch you, those of you who are like at the highest level brilliant, to make you think a little bit on your own. Do we have time to get into this?
There is 2 minutes.
Yeah, let's get you started. Maybe we can finish tomorrow. What? Go away. What? Okay. So it's not an AP test, but it is part of a lot of college calc textbooks. Arc length of a polar curve. Don't reinvent the wheel. Start from parametric arc length and theta as the parameter. When your theory is complete, verify with a polar equation for which you know the arc length. So I'm thinking maybe circle or something like that, yeah? That's not a circle, obviously. So I want this length, yeah? And then add lots of them. So did you start with parametric? What's parametric? The x d theta squared plus
Multiplied by d theta. Well, no, it's just the d theta, right?
and it's d theta, yeah. So when do we use dx d theta and dy d theta? Slope calculation. Does that help? I was thinking that's not good, is it? What about r's and thetas? What's r's and thetas relationship to x's and thetas?
R equals R cosine.
X equals r cosine theta, right? So why is r sine theta? Does that do anything for us? Take the derivative. Dx d theta is? Well, we'll finish going over it tomorrow. I think this is going to go somewhere. Is that what you did? And it went somewhere? Interesting. Okay. I will.
I can't find Frenchie with staple. I don't know where it went.
I feel like you guys kind of all touch with each other.
I'll go back in there. Can you put my name on there? And I'm also a music.
Okay. You guys can all work it out. I don't. It's not really. It's not there. I don't.
I'm not really sure. Which means I haven't really been doing it. Yeah, Friday it was so bad. I like couldn't get out of bed until 11 o'clock p.m. And when I finally got out of bed, my mom took me to the doctors to get a strep test. And then they're like, you don't have strep. You might have influenza. And then they're like, you don't have influenza. Because I'm in the hospital, there's like every type of contagious thing going on right now. And then she's like, yeah, so pretty much
Did all your kids take the test?
any of the symptoms of these.
I don't know what I'm gonna do because one of them I couldn't. She got required by somebody else before I
He's like,
My kid's
what?
going to take
And
an
so
class
like, I can
tomorrow.
go.
They're taking in class. So when are you gonna go over it?
Nothing.
Class
It's just
So
like,
you're gonna put it
yeah,
out
you
the
put like a
hallway?
headphone. Bye.
That lesson is long.
Yeah.
I mean, it
Do
took me
you
up.
do so on that relation versus function part? Is they do you have them dot the relation?
I didn't even talk about calculating. I had them get out their calculators, and I had them say, no, let's take out the calculators, tell me this. And why? Why is it just graphing this part of the graph? And we just really stressed about inverses. So they're gonna look at the back and they're gonna see all those dashes in there. And I'm just gonna tell them. I don't want you drawing those.
So you're gonna say ignore the directions and just draw the function?
I want to see what an inverse graph looks like, because I wanted to explain why we have a restricted range. Isn't that what we care about? You tell me.
No, I don't care. I mean, there's an inverse relation, there's an inverse function. I don't know.
I guess I'm talking about inverse function. I will also say this. It does help them when they draw the whole thing because it makes them think about snaking around the axis. I mean, how many times do you get them where, you know, they've got this point, this point, this point, right? And yes, they'll bend the wrong way. Now, I always tell guys, you've got to snake around the axis, so I actually do both of them. I said, okay, so guys, does it go this way, or does it go this way? Which one will, and then I also, you saw me say go towards the asymptote, so it helps them. My seeking graph, you know, it's got to diverge, but it's got to go towards the asymptote. I'm sorry. It's got to go towards the asymptote. This is the exact opposite I'm saying. Like, it does help them that you always approach an asymptote. Well, the way that I actually do it on a test, I think you'll appreciate it the way I wrote it. I have drafts that go a long way. Yes, I used to forever to draw because I had a picture. You can't put it in a function. It tells you exactly what I wanted it to do. So I ended up doing cubes, and then I had to like cut them off. It was the biggest pain of my life. It probably took me an hour. So I put them in there. They'll still make it wrong. But that to me was good. That was a good exercise. But again, or is it just that we care that they understand why they have restricted range when they master the what do I care about? You do care about understanding those with this class?
Yeah,
That's what she was hard.
inverse graphs and all that
That's true.
I
But I always
just
do
did.
it.
Aren't they? I did oh my god. Very wide. Over here. Jared, you play Overwatch? Makes me stare at me now.
How else do they do placement of approaching and things?
I still think that my kids would have said, well, I know that I've been doing it.
Oh,
They would go to the yes, and they would think, oh, I'm going to do that too. I think that's how my kids would have done it.
that's kind of right, but that makes sense. Hi, people. How are you?
I'm good.
Oh, good, good. Thank you. Excellent.